Well, I'm going to tell you something about liquid ring machines, vacuum pumps and compressors. First, I start with an introduction on liquid ring technology. First, some basics about vacuum, because my assumption is from other seminars and so on that most of the people are used to deal with centrifugal pumps, liquid pumps, and to handle gases is a bit different. And I will give you some basics on that first, and then I go to the liquid ring technology, how the pumps are operated, and finally going to some typical applications for these machines in the petrochemical and refinery business. Yes, what means vacuum? In principle, it's the same as you do with a centrifugal pumps. You bring, in this case, a gas from a point A to a point B, where the pressure in B is higher than in A. Sounds very easy. On liquids, we have a constant mass flow and a constant volume flow, because liquids are not compressible. When we talk about gases, the mass flow is also constant, but the volume flow is decreasing with the pressure, with the rising of the pressure. That means when you go down in vacuum, you go down in pressure, you need a big pump to handle the big volume. Oops, sorry. Yeah, so this is exactly what it shows. Normally, when you go down in pressure, you need a bigger pump from looking at the volume than in the higher pressure ratings. When do we talk about compressor and when do we talk about vacuum pumps? There's always a discussion because the machine looks very similar and is more or less the same. We always talk about a compressor when on the suction side we are in atmospheric range of the pressure. So we compress the gas from atmospheric pressure to overpressure. Typically we are talking about bar as a unit for the pressure then. When we talk about vacuum, we mean a pump which handles pressure from a lower pressure, below atmospheric pressure, and compresses it to atmospheric pressure. In this case, we normally talk about millibar, and yeah, that's the major difference. When we talk about the vacuum side, we have different steps of vacuum which are defined. We have the so-called rough vacuum, which starts at 1 millibar absolute and up to ambient pressure. The fine vacuum going down to 10 minus 3 millibar, high vacuum 10 minus 6, and then the ultra high vacuum to 10 minus 13 bar. When we talk about the applications mentioned in the beginning in chemistry, in petrochemistry and so on, we are normally talking about this range between 1 millibar and atmospheric pressure. And in this pressure range, liquid ring machines are operated. For the lower pressures, liquid ring machines are normally not suitable for reasons which are linked to the operating principle with the service liquid, because you can decrease the pressure only down to a level which is slightly above the evaporation pressure of the service liquid, because otherwise the pump would fill with steam and would be blocked by the steam and cannot operate anymore. Working principle. A very simple picture to show how this machine is running. An impeller is mounted eccentrically in the casing. That means, and due to the rotating forces, the service liquid is pushed to a ring concentric to the casing. That means, when rotating, you have on this side an opening volume between the impeller blades and the liquid ring and the hub. So in this stage, the gas is being sucked in due to the increasing volume. In this stage, the gas is being compressed, and here, when the gap is getting closer and closer, the gas is being discharged.